Well, hello pre-calculus students. In this video, we are going to work on just applying this equation that we had up here. So say you had a principal of 1100, a growth rate of 8%, and a time unit of 7, we'll say 7 years. Then the amount that you would have after 7 years would be equal, or 7 units of time would be the principal, P, in this case is 1100, times the special number E raised to the R, and R here is 8%, or 0.08, times T. So that's multiplied by 7. Okay? And then we can put that into a graphing calculator, or really any calculator, and we will get 1925.74. And this is kind of an abstract example, so I'm not talking about money or population or anything like that. This is just a number here that we're using. All right, and I'm gonna skip the next example, and I'll let you kind of figure it out yourself and how to apply it. And I'm gonna do a different example that involves a different type of problem solving. So Joel invests $8,000 into a retirement account with 9% interest, compounded monthly, right? So monthly is 12 times per year. How long will it take until her account grows to 16,000? And so we set it up as follows. We start with the principal of 8,000, and it is going to be 100% plus the rate, 9%, divided by 12, because we're compounding this monthly. And we're going to do this 12 times per year for some unknown number of years, or T here. And we want this amount to grow into 16,000. Okay? So you can see that the way that I have this set up here, it's just an equation, but rather than using continuously compounded, we don't want to lose sight of what compounding means. In this case, it's compounded monthly, so we use 12 rather than the special number E. And then we'll solve this out as best we can. So divide both sides by 8,000 and we get 2. Okay. Is equal to all of that raised to the 12th power. All right. And then in order to get this, actually I'm going to compute 1 plus 0.09 over 12. So this is 2 is equal to 1.0075 raised to the 12t. Okay, and then to take care of to get rid of that exponent, I could take the log base of 1.0075, but for the sake of using a calculator, I'm going to take just the common log of both sides. And so that allows me to take this 12 out to the front using the power rule. So this is going to be 12t log of 1.0075, and then common log of 2 on this side. And this is a multiplication here. So continuing this problem, we're almost done. Log of 2 divided by log of 1.0075 is equal to 12t. And then multiply both sides by 1/12, and we'll have our answer. So in this case, we end up with approximately 7.73 years here as our units of time. Okay, so about 7 years and 9 months. Okay. All right, and then I'm going to do one last example here, this time with compounded continuously. So the key word here is continuously. So Leslie invests $100,000, and her interest is compounded continuously. At what rate of interest? So we want to find the rate, right, does she need in order to double her money? So we start out with $100,000. That's our principal, times e to the RT. And t in this case is 20 because we want to double our money in 20 years. And we want the money of $100,000 to grow to 200,000. Okay. So from here, it's fairly straightforward. Divide both sides by 100,000, and we get 2 equals, I'm going to rearrange this a bit, 20R. And I can take the log of anything, but it's easy. It's a bit easier here if I take the natural log. So if I take the natural log of 2 on the left and the natural log of everything over here on the right, we can see how this turns out really nicely. So on the right here, I can take the 20R out to the front, and then I end up with the natural log of E. Okay? But the natural log of E, I'll write on a side note here, that the natural log of E is just equal to 1. Okay, so I'll let you kind of dissect and figure out why that's the case, but the natural log of E is always equal to 1. So I can cancel this altogether, and over here I have the natural log of 2. Okay, so my final answer here is the natural log of 2 divided by 20 is equal to R. So this turns out to be approximately 0.03465 is approximately equal to R, or we can say 3.465%. Okay, either one of these would be perfectly good and acceptable. And so that takes care of the first part. What if we invested $5,000? How long would it take us to double our money? Well, I'll set this up for you so that you can see it actually makes no difference, right? That if you started out with $5,000 and we have E to the sum rate of 20, and we want to double our money, so we want to get $10,000 before it's all over, within 20 years, divide both sides by 5,000, and we end up with 2 is equal to E to the 20R. Okay, so from this point here and this line here, you can see that it's all the same, so it doesn't change at all. So how does our answer change? It doesn't change at all. If for whatever amount that you invested, if you're trying to double it, all of the logic will work out exactly the same way. As always, thank you for watching. Keep working hard and have a wonderful day.